In this topic, we discuss adding and subtracting unlike rational expressions. Let's now summarize our procedure for adding unlike rational expressions. That is, rational expressions are fractions that have different denominators. Step 1. Find the LCD, the least common denominator. Step 2. Change the fractions to have the new denominator. That is, multiply the top and bottom of each rational expression by its missing factors to transform the denominator into the LCD. Step 3. Add the now like rational expressions by combining the numerators and putting the result over the LCD. Step 4. Reduce the resulting rational expression if possible. This is the main idea of our video, to add and subtract unlike rational expressions. To add unlike rational expressions, apply the above procedure. To subtract unlike rational expressions, we'll first change the problem into an addition problem by distributing the subtraction and then applying the above procedure. Let's take a look at some more examples. Example 1. Add or subtract. Write the result in lowest terms. 1a. 4 over 9t cubed plus 1 over 6t squared. We observe that we are adding two rational expressions with unlike denominators. So our first step is to obtain the least common denominator. Let's do that. Let me write down 9t cubed into prime factors. 9t cubed is 3 times 3 followed by a product of 3t's. Similarly, let me write down 6t squared into prime factors, which would be 3 times 2 and then a product of 2t's. The least common denominator, the smallest expression that both 9t cubed and 6t squared divide into, consists of 2 3's, 3 times 3, 1 2, and 3t's. Or, if you like, our LCD is simply 3 times 3 times 2, which is 18, and t cubed, t times t times t. That makes sense. 9t cubed and 6t squared both go into 18t cubed, and in fact this is the smallest thing they both divide into. Alright, that completes our first step. Now that we've obtained the least common denominator, our second step is to convert each of these fractions or rational expressions to have this new denominator of 18t cubed. I'm going to begin by taking my initial problem here, and I'm going to rewrite it so I have more space. I'm going to put 4 over 9t cubed plus 1 over 6t squared. And we want to rewrite this into a problem where the denominators are the same, that is 18t cubed. So our job is to change the numerators so that this new expression has the denominator of 18t cubed. How do we do that? Well, let's ask ourselves, 9t cubed, what would I need to multiply by 9t cubed to give me 18t cubed? Looking at the numbers, it's easy to see that we need to multiply this by 2. 2 times 9 is 18. The t cubed stays the same, so we don't need to multiply by any t's. So the only thing we need to do is multiply our denominator by 2. And likewise, whatever we do to the bottom, we must also do to the top. That means we need to multiply the numerator by 2 as well. That means our new numerator is 2 times 4, which is just 8. Let's look at the second fraction, or the second rational expression, 1 over 6t squared. What do we need to multiply by 6t squared to obtain the least common denominator of 18t cubed? Well, we need to multiply the 6 by a 3, because 6 times 3 gives us 18. And t squared is missing a factor t. t squared times t to the first power gives us t cubed. Whatever we multiply by in the denominator, we must also multiply by in the respective numerator. So that means we have to multiply the numerator by 3 and t. That means our new numerator is 3 times 1 times t, or just 3t. Good so far. We've now completed the second step. The third and final step is to now add these rational expressions. They're like denominators, so we know how to do this. We combine our numerators and keep our denominator the same. So we have 18t cubed as our denominator, and our numerator is simply 8 plus 3t. Observe 8 and 3t are not the same. They're not like terms. Therefore, they can't be added. So this would be your final answer. 8 plus 3t over 18t cubed. There's nothing that factors out, so there's nothing that will cancel. Some people prefer to rewrite this answer so that the variable term is first. So some people prefer to view this as 3t plus 8, again over 18t cubed. Either answer is the same. And again, you can't put the two terms together because they're not like terms on the top, and you can't cancel anything. So to add 4 over 9t cubed plus 1 over 6t squared, we obtain 3t plus 8 over 18t cubed as our result. Example 1b. Subtract and write the result in lowest terms. 6 over z plus 1 minus 2 over z. We first observe that our rational expressions have unlike denominators. Also, we're going to be subtracting them this time. So we begin as before. Our first step is to find the least common denominator. Now notice, both of these denominators are already factored as far as possible, but I'm going to write them down anyways. Z plus 1, that's our first denominator, that's already factored, can't do anything with that one. And z, likewise, that's factored, can't do anything with that. So our LCD is comprised of both of these factors multiplied together. Z times z plus 1, that's our LCD. That completes the first step. Our second step is to rewrite each rational expression to have this new denominator. So I'm going to rewrite my problem, and I'm going to leave some space because I know I'm going to be multiplying. I have 6 over z plus 1 minus 2 over z. And I know that I want to obtain in the denominator z times z plus 1 for each of these rational expressions. So what is it that we need to multiply by in the denominator and the numerator to create the new fraction with z times z plus 1 in the bottom? Well, we're starting with z plus 1. And what is it that's missing? What factor is missing? The missing factor is z. I need to multiply z plus 1 times z in the first rational expression. And whatever we do to the denominator, we have to do to the numerator. That means my new numerator is 6 times z, or simply 6z. Moving on to the second rational expression, we have a z in the denominator, but we need to obtain z times z plus 1. So the factor that's missing and which we need to multiply by is z plus 1. Z times z plus 1 will match. Whatever we do to the denominator, we must do to the numerator to create our equivalent fraction. So on the top, we actually have 2z plus 2. We now have two fractions with like denominators, and we proceed to subtract these fractions as we did when we subtracted fractions that have like denominators. The key thing to remember here is that there's a minus sign. So we must remember that when we're subtracting, we need to subtract every term that's in the numerator on the second fraction. So let me rewrite. The numerator, so first of all, when we add, we have a like denominator, so our denominator is going to be the same. It's z times z plus 1. But when we combine the numerators, we're going to have 6z, and then minus 2z, and then minus a positive 2, which means minus 2. The numerator is 6z minus 2z minus 2. Be careful with this subtraction and make sure you distribute it through. Let's simplify by combining any like terms in the numerator. Notice we have a 6z minus a 2z. And when we combine, that gives us a 4z minus 2. All over z times z plus 1. We can't do anything else as far as simplifying, but can we reduce our fraction to lowest terms, or is it already reduced to lowest terms? Well, the key, remember, is to factor. And notice, actually, we can factor something out in the numerator. Notice we could take out a common factor of 2. If we were to take out a common factor of 2, we would be left with 2 times 2z minus 1 over z times z plus 1. However, notice now that there's nothing here that can still cancel out. 2z minus 1 appears in the numerator, but neither of those factors appear in the denominator, and likewise z and z plus 1, neither of those factors appear in the numerator. So these two answers are equivalent, meaning that you are already reduced to lowest terms. So either answer would be acceptable. 4z minus 2 over z times z plus 1 is the difference of 6 over z plus 1 and 2 over z.